Welcome everyone to Digital Dental Forum's webinar series. I am Dr. Bhavin Patel, and today we'll be speaking about 3D printing as part of the digital dental workflow, which I feel is definitely set to grow as we go forwards. So Abraham Lincoln once said, "I do the very best I know how, the very best I can, and I mean to keep on doing so until the end." And it is this sentiment that has been transforming industries and creating innovation over the years. Along the first industrial revolution, we saw water and steam power with mechanized production moving the industry in its initial phases. In the second revolution, we moved to electric power and mass production. On the third industrial revolution, which I think most of us can look at, we have electronics and information technology, computers as most of us know them. And now we are witnessing the fourth industrial revolution with cyber physicals and Internet of Things. Dentistry is not very different. If you see, we see Dr. Franco Dure, the father of dental CAD/CAM, in his lab in 1979, and that's where he got the concept of subtractive manufacturing for dentistry. Here we have Charles Hull in 1986 inventing the 3D printing technology, which now is being widely used. So currently, the where we stand in dentistry is we have different scanners, mill machines, different printers. So a lot has moved as far as digital dentistry is concerned, and I would say it's almost become mainstream. And going forward, I see that just growing with bigger machines, better machines, faster, and also in terms of material sciences, we are seeing a lot. So what is 3D printing or additive manufacturing as it is known in industrial terms? It is the manufacturing process in which material is laid down layer by layer to form a three-dimensional object from a computer-aided design model. So how is this different? We hear a lot of terms additive manufacturing, subtractive manufacturing. So what is the difference? How are they different? So in terms of additive manufacturing, you start with a block or a material disk, as in zirconia. And then we mill out hollow structures using rotary tools, using milling machines, and that gives us our desired object. But what this does, it also gives us a lot of waste material. And I believe a study said that it's almost 80% wastage, you know. So basically, you're throwing away 80% of the material, which is doesn't make a lot of great economic sense, or the environmental impact also needs to be considered. Whereas with 3D printing or additive manufacturing, you start with the material, it could be a powder, a resin, and you build it using a 3D printing machine to get an object. And the wastage is very little. It's believed to be about 2 to 5% only. So not only is additive manufacturing a better option in terms of economics, but it also helps us save the environment. So what is 3D printing in dentistry? What are the things that we can do? So of course you have the basic indication of creating models, ground and bridge, castables, you have your partial frameworks, you have your temporaries, you have custom trays, which are now being seen more and more in use when it comes to implants. You have splints, again, a very potential and growing indication, surgical guides, aligners, indirect bonding trays, and of course, the denture. So moving ahead, how does a digital workflow work? How can one achieve a good digital dentistry outflow? So the steps are simple. One, of course, is scan. You can use intraoral scanner or a lab scanner to capture the data. Additionally, if you want, you can also use CBCT data and then subsequently merge them in a planning software. ExoCAD, 3Shape seem to be two of the most popular ones on the market. You can choose whatever you like. Once you've planned your prosthesis or the object, you need to go in for production through milling or through printing, whatever you may decide depending on various factors. And then subsequently, the tooth or the restoration is delivered to the patient. So this is in short the digital workflow. So that brings me to a next question that a lot I get asked quite often. How do I select the right printer? Now, there are a lot of things that do go into this. So, one, of course, the most important is the printing technology. So, first, we had the SLA or the stereolithography machine, where a beam of laser is incident on a resin vat, and the objects are drawn pixel by pixel, layer by layer. And Formlabs is a good example that uses this technology. Of course, the disadvantage of this technology is it is very slow because every pixel has to be written down piece by piece, piece by piece. And in today's day and age, I think time is money. So we are seeing a lot of people move to the digital light processing system. So the basic one here we have is the color LCD, where there is a color LCD is the light source. It gives out light across different spectrums. And by the use of filters, the other spectrums are reduced, only the UV spectrum is used. And another set of filters creates an image of what needs to be produced every layer on layer. Now, these filters act very similar to what we did in childhood, where we used our fingers to create shadows on the wall in front of a light source. So these filters act as uh, creating image every layer by layer. So as you can see here, the light is incident through filters filtered into a resin vat, creating layers after layers of the final product. Now, this technology is very difficult because the life of the LCD tends to reduce very quickly. So the next step was to create a mono LCD where the light source created spectrum-wise production. So you used only the UV spectrum, which is most predominantly used in 3D printing. However, the filters to create the image layer still continue. So that still creates a lot of energy loss. Plus, there is also some sort of light leak. So if the filters are not very sharp, you tend to get very blurred borders, or you tend to get flakes around the 3D printed product. And also, speed is an issue with the LCDs. The life of the LCD itself is an issue. So you need to consider all of these factors when you go in for an LCD printer. They are cheaper, but they will require replacements much sooner. And also, the predictability is questionable. Now, in terms of DLP, the LED projector, UV LED projector printers seem to give the best performance, the most predictable performance. Here, you have a projector giving out UV light, which is passed through a series of mirrors into the resin vat, and every layer is produced to give you the final object. Now, 3D printing resolution. Now, this is a very big misnomer. We have seen a lot of people, a lot of advertisements saying HD, 4K, 8K. So, what is all this? This is nothing but a two-planar 2D XY dimension of the pixels that are there. When you're buying a TV, yes, that's great to have this. But in terms of printing, what the resolution does is it only ensures a smooth surface. It in no way, I repeat, in no way gives accuracy. It's only the smoothness that matters. Besides, you also need to understand that we are doing 3D printing, so you need to consider all three axes, the x axis, the y axis, and the z axis. The z axis being the layer height. So the high resolution comes with a trade off, longer print times. So you could have 25 microns to 100 microns. So that's something that you need to decide based on the indication that you're printing. So that brings me to the next subject of accuracy and precision. So there is no true relationship between accuracy and precision. The accuracy of a print refers to how well that object conforms to its original form, while resolution is simply the smallest feature that can be printed in a particular plane, whereas precision is repeatability. So let's look at this chart of accuracy versus precision, or repeatability as we should actually refer to it. Now you have a printer that has a low accuracy, a low precision. So it's basically a hit and a miss. Now, then you have printers that have a high accuracy but cannot give a repeated performance. So you have a good print one day, you have a bad print another day. So it's not predictable, so you don't want to rely on something like that. Then the other side, you have printers that can give you repeated production but are not very accurate. So yes, they will print something, but whether it is usable or not is something that needs to be ascertained. And then, of course, sorry. And then, of course, you have printers that have a high accuracy and a high repeatability. Now, these are the ones that we need to look at because you want a good print, every day. These printers, of course, have a lot of systems put in place to ensure this level of accuracy and repeatability, and therefore are slightly on the expensive side. Another thing to consider is the printing envelope. So, like I already spoke about, you have the X, Y, and Z axis. So, the cube that is formed, in terms of the printing platform, in terms of the height, will give you the printing envelope, which nothing defines the quantum of work and the availability of printer that can be done. Moving ahead, with digital dentistry, this is a very important thing that everything needs to talk to one another. Your scanner needs to be able to accept files from your scanners, from your design software, from, it needs to play well with others. So you need to have the freedom of operating systems. You need to have the freedom to choose how you want to connect your software and your various hardware. So you need to see a whether it works on the operating system of your choice, on the data transmission channel of your choice, and of course how well it plays with the other digital dentistry softwares that you may or may not have or plan to get in your practice or the laboratory. The other one system is the 3D printing materials. Now, we see a lot of printers that are closed or that are limited in terms of the resins that you can use. Now, I find that to be quite a handicap because if I'm paying for the machine, I would want the freedom to choose the material of my choice. And today, trust me, there are so many resin manufacturers, so many resins available that to give up on this choice is just criminal. So you might want to buy a printer that has an open material system. And you also need to make sure that the resins that are accepted by the printer are available in India. Of course, technical support, we all know in digital dentistry is a huge part of the decision making because there will be hand holding, there will be issues that will come up. And if you don't have a vendor that gives you good service and support, now this support could either be online or it could be physical at your office. You need to consider that. And also, in terms of the cost of the machine, you need to add the cost of the support, whether there is a monthly fee, annual fee, quarterly fee, or is it free? So that's something you need to know upfront because that will also, add to your cost of ownership. So service is an important part, and please do consider this. All right, so that's all from me for now. I'm open to take any questions. Thank you.